Howdy, my name is MilesMikeska. I am from El Dorado, Texas. I come from a farm. My family and I farm cotton. So I've always had an interest in agronomy, always felt that I was called to do something in the field of agriculture. I got my undergrad in the Soil and Crop Science department, graduated in December of 2015. I started my master's in January of 2016, and I'm currently working on getting a master's in agronomy, and my project is high throughput phenotyping in cotton. So phenotype is it's a product of a plant's genotype and the environment in which it's grown in. So what I'm doing is I'm using a bunch of high-tech sensors to automate the process of field phenotyping. So before, traditionally a plant breeder would have to go in here and take measurements by hand. It's a very slow and tedious job. What we've done is we've automated this process. We've used some new technology, we've integrated some old technology, and what we're working on is laying out the platform so that hopefully in the near future plant breeders can use a machine like this one behind me to go through their field, take phenotypic data, and then select plants for desirable traits that they have. So behind me we have a 4-row plot sprayer. This machine was used to spray small plot fields. So when we needed a vehicle, we decided to use this one. We took all the spraying equipment off the boom, and then we built these brackets to mount our sensors in order to take our phenotypic data. So up top we have an NDVI sensor. This measures essentially plant health and plant leaf area. How healthy, how big is the plant? Right here we have an IRT sensor. This IRT sensor is an infrared thermometer. This gives us crop canopy temperature. How well is the plant cooling itself? Down here we have a sonic sensor. This sensor here emits a sound wave. It receives a reflected sound wave. That gives us the height. So we have plant greenness and health, we have plant canopy temperature, and we have plant height. We can put all these three together in order to get phenotypic data that we desire. So all these sensors are wired into what we have here is a data logger. This is essentially just a big computer. This computer is being talked to by a GPS. So we can take all these data points and map them with a GPS point so that we know where exactly in the field each data point was taken. So all the measurements we're taking with this ground vehicle are being compared to measurements we're taking with a UAV. So we teamed up with the Department of Aerospace Engineering and decided that, okay, we have ground data, now we need aerial data. So the aerospace engineers built us a UAV that we can fly over this field. When we're up in the air, we're taking pictures using a multispectral camera. This gives us all sorts of wavelengths of light. We're also taking pictures with a thermal camera. This tells what plants are cooling best, what plants aren't. So we're taking ground temperature data, we compare that to aerial temperature data. We're taking NDVI on the ground, we can compare that with the multispectral camera up above. So all of this is being done so that one day producers or crop breeders can go across their field and take data in a much quicker manner. Right, so after graduation, I hope that I can take the information that I learned here and use it as a crop consultant. I really think the new technology we have here can be applied to producers and help them to better manage their farms.